Hello everyone, welcome back. Today in this video we will talk about standard deviation and variance, but before that we need to understand what is sample and population. So I will explain you this with an example. So consider 8 billion people on the earth and we want to know the average height of people. So it is not possible to go to each and every individual and ask their height and then divide it by 8 billion. So what we do is we randomly select certain individuals. So let's say we randomly selected around 1000 people and we asked their heights and then we averaged it and we consider that as a representation of population's height. So that is what is the importance of sample. So here I will show you some different notations. So if we are considering the mean of the population, it is being denoted by mu, and the population size which I gave you just now was 8 billion, so that will be represented by capital N, and the population variance will be denoted by small sigma square. So that is the representation of mean, population size and population variance. Now there is a slight change in the representation of sample mean, sample size and sample variance. So sample mean is being represented by x bar. There are a lot of different notations. I personally like to use this, so I'm just giving you notation because I will be using these notation in further videos so that you won't get confused. And the sample size is denoted by small n, and s square represents our sample variance. So these are the notations, and that's why we usually use sample instead of population, because we never know whether the data which we have is representing a whole population or not. Usually it's a sample, so we never use the formula for standard deviation and variance for population. Yes, if you know that yes, it is the whole population and this is the possible data which we could gather, so in that case you can definitely use that, but most of the time we use the sample. Now with that being said, let's move on and see our standard deviation and variance formula and how we can calculate it. So the formula of variance is we take the mean of our population and see the distance of each value from the mean, and then we square it and then we sum them all up and then we divide it by the population size. So that's what our variance is, and if we just take a root of it, it will become standard deviation. So that is for population. There is a slight change when we want to calculate these values using our sample. So you see everything is same, is just in the denominator, instead of using our sample size we are doing n-1. So you might ask why we do n-1. So this is also called degree of freedom. So what does a degree of freedom means? So let's say we'll take this example itself. So in this you can actually calculate the mean of them. So you will just calculate the mean of them, and let's say it is x bar, and if you know the mean and if you know n-1 values, you can actually calculate what will be the nth item. So just because of that we use n-1, and when we use n-1 it actually gives a better representation of population's standard deviation. So that's the reason why we use n-1. We'll also see it in our code where we can actually specify how much degree of freedom we want to specify. So we will see that in our notebook section when we will move on there. And you might also ask why we are using square here. So the reason why we are using square is whenever you will subtract mean from your value, sometimes your value will be larger, sometimes your value will be less. So if you don't do square, so it will not become positive value, and then it will start to subtract each other out, so it will not give a very good representation. So that's why we do square. We will get to understand it much better when I will just use this particular example down there, and this will give you a very good understanding of it. So to calculate our sample variance and standard deviation, we need to first calculate our sample mean. So to calculate sample mean, we will do 2 plus 1 plus 7 plus 6 plus 4 divide by 5, which will give me 20 by 5, which is 4. So that's what we have got here, and now we will calculate our sample variance. So how do we calculate sample variance now? So we will do 2 minus 4 square plus 1 minus 4 square and we will divide it by 5 minus 1. So this will give me 4 minus 2, 2 squared 4, 3, 9, 3 again 9, 2 again 4, 4, 0, and we divide it by 4. So 26 divided by 4 is 6.5. So for this particular example, we are getting our variance as 6.5. Now we will try to calculate our variance. For standard deviation, you can just take a root of it. So your standard deviation will be root of 6.5. Now we'll try to calculate our variance for this particular example, which is example 2. So again, we will start with calculating mean, which is again 4. Now we will again put this value into our formula, which will be 5 minus 4 square, 4 minus 4 square, 4 minus 4 square, 5 minus 4 square, 2 minus 4 square. Now we will divide it by 5 minus 1. Now here we will get 5 minus 4, 1, 0, 0, again 1, here we will have 4. So now we will have 6 divided by 4, which will be 1.5. So this is our variance, and if you want to calculate standard deviation, you will just take 1.5. Now the important thing to note here is, even though our mean was 4 in both the cases, the standard deviation of the example 1 is bigger as compared to standard deviation of example 2. Now we will try to analyze it intuitively. If we look at the elements here, you see all the elements are very closely clustered. Most of the elements are very close to 4, 5 or something, but here you can see the values are very much spread out. There are values like 2, 1 which are very small, and then there is a big value which is 7, 6, and then there is a value called 4. So you can see that it is giving a very good understanding about how much your data is deviating from the mean. And this we can actually use when we will look into distributions, let's say a normal distribution. So there you will see if a value is lying, let's say, outside of 3 standard deviations, we can call it as an outlier. So we will see about that in our distribution section, but this will give you overall idea what is the importance of variance and standard deviation. So now let me take you to our notebook and show you how you can actually calculate it. So again, we are using PyDataset package, and from that package we are using Boston dataset, and I'm just printing head here so that you can see some values, how they are. And to get the sample, all you have to do is df.sample. So now what is df? Df is just a variable which is holding our dataset. So it need not be coming from this particular package. You can just do pd.read_csv, so you can read any CSV file. So that is what you can do, and you can store it in a variable. And if you do df.sample, and if you give n equals to 50, it will randomly select 50 samples from the dataset. So that will be your sample, and we are considering our data frame or the whole dataset which has 500 rows as a population. So we are doing df.describe. It is giving us important statistics about our population, and when we do our sample.describe, it is giving us the important statistics of our sample. So now the important thing to look here is, let's see, we want to see mean of age. So here we have mean of age which is 68.57 in our population, and in our sample we are getting 64.39, which is actually pretty good. In past video we had seen that the range of the age was around 97. So considering that, the mean that we are getting here is pretty good. So our sample is giving us a very good estimate about our population. So we can actually take this value as a good estimate of our population mean. So that is what is there. But also if you want to calculate let's say standard deviation and variance, so standard deviation is actually here, which you can see, which is sample standard deviation is 29 and our population standard deviation is 28, which is again quite close. So you can also use NumPy to do that. And here what I was talking about, degree of freedom, which you can see here, which I have given as 1. So this one means n minus 1 that we do, this is the one which we are giving. So by default when you do describe and this is being calculated by pandas use n minus 1 by default, whereas NumPy does not do it. So if you want to calculate your standard deviation and variance, you will have to specify degree of freedom if you want to calculate a sample standard deviation and variance. So yeah, you can see here, if I show you standard deviation of our population with degree of freedom 1, it is 28.149. and if I show you here what pandas has calculated, which is again same, but what you can do is in your exercise you can remove this DOF and you can calculate again, and you can see the difference between how the NumPy calculates and how pandas calculate. So it's not like one thing is wrong or right, it's just what you want to calculate is totally dependent on that. Now as for your task, what you have to do is try with different sample size and analyze how the statistics of the sample is changing, because sample size is actually very important. Because if you take very small sample size, it might not give you a very good indication of your population statistics. So it's important to choose right sample size. So try to choose sample size which is very low, like 10 or something. In this case our population is very small, so it probably won't affect much, but it's always good to try different things. So you can try for let's say 10, 15, and you can also try for 100 or something. So that will give you a very good understanding of how your statistics is changing based on the sample size. So yeah, this is it for this video. I hope you found this to be helpful. Hope to see you in the next one. Happy learning.